Welcome back, guys. So today we'll be continuing probabilities. So today we'll be seeing Poisson distribution. So let x be a discrete random variable with parameter mu that is greater than 0 is said to have a Poisson distribution if the PMF is given something like this. PMF is in the form of f of I that is equals to p x equals to I. This is e to the power minus mu times mu to the power I upon I factorial, where I is equals to 0, 1 and so on. There are some things to note. So the number one we need to note is that Poisson distribution geometry as PD can be only applied when there is a sequence of changes within a certain time period. Sequence of changes in the interval 0 to t. And number two, for that, here mu is equals to lambda t. So mu which we have used is equals to lambda t. So lambda is the number of changes per unit time, t is the total time, and mu is average changes, average number of changes in time interval 0 to t. I'll just like one more note, so like where this can be applicable. So note, like we can transform a question of binomial to Poisson by just binomial to Poisson by applying mu equals to np, and that only is possible if n is very large and p is very small. That is something like this. So this is a question: if there is a war in every 15 years, what is the probability that there will be no war in the next 25 years? So you need to identify the question and need to identify the parameters. So first of all, we have from question is that lambda is equals to number of bars. So that was number of changes we know. So we'll consider in each year. So that will be equals to 1 by 15. So because in every 15 years there is a war, so in 1 year it will be 1 by 15. The total time period we have for this question is 25 years, simply 25, and we need to find the mu, that is lambda times t. So 1 by 15 times 25, that will be equals to what? 5 by 3. So now suppose we denote x equals to number of bars. So the required probability is required probability p at x equals to 0, because we need to find this will be to the power minus mu, that is 5 by 3 times mu to the power, so this will be plus 5 times I, that is 0 upon I factorial. So solving this we get e to the power minus 5 by 3 as our answer. So this is the required probability. Again we'll just write something here, like if x be a Poisson mu variate, then we can say that number one, mean of x equals to mu, and number two, variance of x, that is equals to mu. So these are some two properties that is also important. So this was all about it. So thanks for watching it.